Welcome back to my channel Workshopfriend and my series on upgrading my small lathe. Last episode I introduced the lathe to you and some of the limitations, and I started to work on a new cross slide. Today we're going to continue working on the gibs. Most of the work today will be done on the shaping machine. There were one or two problems which arose, and so I produced a little bit of technical content in this video which I hope you'll find interesting. So we'll go straight to the workshop. I'm just setting this up for taking about 30 thou off. So here you can see one of the gibs on a jig which I made in the previous video. We're going to be taking roughing cuts on all four edges, and the reasons for doing this were covered in the previous video but are due to the fact that this is cold rolled material which carries inbuilt stresses. Along the way we're going to be measuring the material, checking it for straightness and gradually homing in on the final size. Touching off for the third roughing cut. After the third roughing cut, I've checked everything's deburred and clean. So let's just see how this looks now. Zero it. Okay, yeah, that's better. So zero at both ends. And in the middle we've got a deviation of just over 3 thou. So we're progressively getting better. It's still convex on the top. I can't do it the other way around because it's going to rock. So that doesn't really help. So I can only check this way. So we'll continue taking progressively smaller cuts, roughing cuts, and I'll leave I don't know, about 8 thou on there for finishing. But before I complete, I want to machine this surface and rough out the dovetail 60-degree angle. So before I go any further with finishing the top and bottom surfaces, I want to rough out the left hand side of this. It has quite a bit of material, about 70 thou to come off there. The finished dimension is 0.1 of an inch from the edge of the screw hole. It's a bit of a funny dimension but that's a dimension I can measure, so that's why I picked that off the drawing. So I've got this piece of high-speed steel which is parallel. I'm just going to wedge that in up against the screw threads so that I've got a reference, and then run a clock along the edge there just to check that it's parallel. So I'll just adjust that so that I know that the two screws are along the axis of the machine. Okay, I'm happy with that. Okay, so just placing the plain side now. be helpful to take a closer look at the top slide and the clapper box on a shaper. Here you can see the cutting tool in red, and in profile you can see the clapper box with its pivot pin. Now in operation, on the return stroke, the clapper box will tend to move forward and up, and that's to provide proper clearance between the tool and the work. In addition to that, the clapper box can rotate left and right a few degrees, and that's also to provide proper tool clearance. Here we have a facing cut with the slide moving downwards. Let's take a closer look at what's happening at the tool face. Here you see the tool progressing downwards. On the return stroke, there is a tendency for the tool to move away from the work, to move upwards, but because the clapper box is in the vertical position, the only path is in a vertical direction. And that's just like taking a facing cut on a lathe and winding the tool out again and getting a slight cut across the surface. Now here we have the clapper box orientated away from the cutting face correctly in the left-hand direction. Again, let's look at what's happening to the cutting tool. This time on the return stroke, if the tool needs to lift or move away, it will move at this angle, and that's nice because it's away from the machined face. So you're not going to spoil the face that you've just cut. The same principle applies for a dovetail or any angled surface. You need to move the clapper box away from the cutting surface. And you can see here that the tool moves in this direction. So again, it's away from the surface that you've just machined. Okay, I've set up a couple of parallels for the work to locate against, and so the first thing I need to do is just make sure that the two parallels are again in line with the axis. Yep, that's good. Okay, now I can confidently locate the gib for the final operation. And I'm just setting over the top slide for 60 degrees. You probably notice a lot of fiddling around here in the setting up, and that's often due to needing to make sure that you clear all the items on the table, including the screw heads for the clamping down bolts and the work, and there's quite a lot to look at, so it usually takes quite a lot of time to get the setup just right. So I've put a scribe line to indicate how far we need to come up with the 60-degree angle. So we're all set up now. So the last operation is just to put a 1/32 chamfer. So I've just rotated the tool and we'll take this slowly. Where you can clearly see the damage on the dovetail with the tool lifting and in fact dropping back down again and creating another dig in at the other end. So let's take a closer look at this and see what caused this problem. Well, the problem was I didn't take account of the angle between the cutting surface and the clapper box. I merely left the top slide in its original position, having just cut the dovetail, and assumed that the clapper box would be all set up for this cut, but it wasn't. Here we have a close-up picture of the tool cutting a nice chamfer on the forward stroke, but on the return stroke, when there was a little bit of resistance, the path that the tip of the tool took was this, and of course that was going to result in a dig-in. What I should have done was to get the correct angle between the cutting face and the clapper box, and the only way to do that in this case was to reset the top slide to the vertical position, and then I had sufficient movement on the angle of the clapper box. So having done that, the path of the tip of the tool was like this, and that was well away from the surface of the freshly cut chamfer, and indeed there was no problem. Now, you also need to pay some attention to the detailed geometry of the cutting tool face. So more typically, you might have this kind of setup where there is some rearward rake on the tool. And if I'm trying to cut that without taking that into account, you can still have a dig in even if the clapper box is tilted away from the work, like this. Now, not because of the cutting area, but because of the tip of the tool, which is further down. And you trace that path and you see again it would cause a dig in. So the correct clapper box setting and the correct tool orientation is necessary, something like this. So in that situation, both the area of the tool which is in contact with the work and the tip of the tool nicely move away from the freshly machined surface. So let's consider a surfacing cut with the work moving to the left, effectively the tool moving to the right. And the question I had is why the tool sometimes will lift on the return stroke but not always. And the first and most obvious reason for that is it depends on whether you have the feed on the return stroke or the forward stroke. And I know that usually it's recommended it should be on the return stroke so that there is no load on the lead screw, or minimal load. But even if your feed is on the forward stroke, whether the tool lifts or doesn't lift can seem a little bit arbitrary. But it's not. Again, it all comes down to geometry. So here we have a situation where the clapper box is set over at an exaggerated angle, as you can see here, with top brake on the tool. And under those circumstances, the tool can nicely ride up over the work without a dig in, and albeit a small dig in, but nevertheless sometimes a visible one. So in this scenario, you may find that with the feed on the forward stroke, the tool may not need to ride up over the work and the clapper box may not need to operate. But even if it does, there is going to be no dig in. But in reality, the angle of the clapper box can be a lot less, and can be less than the angle of the tool, the top brake of the tool, in which case you will see at the end of your work a small dig in. And I have seen that a number of times on my work and often wonder why that's taking place. So a little bit of thought reveals that actually it's all down to geometry, and this means that it might be good to consider having a vertical cutting face on your tool, like this one on the left, or to use a shear tool like this one with a 45-degree angle back rake and a very generous rounded portion underneath, or a narrow down tool, which I sometimes use like this, and I will be using on the next phase of this project to cut the internal dovetails. In each of those examples, the tool will be able to ride up over the previous cut without any dig in. Well, what are the lessons we've learned? The first is that for a clean operation of the clapper box, to avoid dig-ins, take note of the clapper box in relation to the cutting surface, not the top slide. Secondly, when chamfering on the side of a tool, ensure that the tool is also vertical or slightly angled away from the work. Thirdly, avoid tools which undercut unless you lock the clapper box. And lastly, in some operations it may be necessary to lock the clapper box to stop it from lifting, i.e. for cutting keyways in pulleys, for chamfering, and for internal features. Well, I'm happy with how the gibs have come out. It was quite a complicated procedure, but this is a very important part of the lathes, and a bit fiddly, but it's worth getting it right. The tool dug in on the return stroke. The good news, however, is that this is the gib which is against the gib strip, so this isn't actually a working surface. The other one is a working surface, and that one's fine. Now these are 2BA threads. They'll be opened up later for clearance. Just a quick recap from a drawing I showed in the previous video. The two gibs are shown here. The left-hand one, closest to the headstock, has the set screws in for adjusting the gib strip, and the right-hand gib there shows the holding down bolts, which are 2BA, and they were determined by the threads already in the saddle. So I'm going to tap these out 4BA. But I'm not actually going to open these out to the tapping size at the moment. I'm going to drop down a few sizes on the number drill so that I have a suitable drill size to spot through onto the gib strip at a later stage, and to provide a sure location for the set screws to hold the gib strip in place. I've ordered the 4BA set screws and half nuts, and I've also ordered some more 2BA set screws to locate this on the saddle. At a later stage I'm going to counterbore these as well. finally we got there, the 2 gibs successfully machined to the new dimensions, and lessons learned about angles and setups on shaping machines. I hope you join me for the next video to come out soon, when we'll be moving on to producing the dovetails in the cross slide. Thank you.